have a formula that is MC2 into NC2, where M lines intersects with N lines to form a parallelogram. 5 factorial represents the arrangement of 6 gentlemen and 6P4 represents the arrangement of 4 ladies in 6 positions. G is not repeating, I is not repeating. So the only cases are 7 factorial by 3 factorial and 2 factorial. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So we are in the revision sessions, and today in this session we are going to see the questions or the important questions which they might ask for your examination from the chapter Permutations and Combinations. And here from the chapter Permutation and Combination, we are going to discuss only 1 mark, 2 mark and 3 mark question. So why? Let's see the distribution of marks here, because in this chapter you are going to expect 1 1-mark question, 1 2-mark question and 1 3-mark questions from the chapter. So we have already learned the permutation is nothing but an arrangement and combination is nothing but the selection. So the methods of doing the permutations and combinations we have learned it, and let's see few questions and solve in today's session. 1-mark questions. So here we have, in how many ways can 10 people be seated around a table? So when I say around a table, it is your circular permutation. We know that in circular permutation, when you are arranging n object, it is given by n minus 1 factorial. So therefore, we are arranging 10 people around a table. So therefore, the total number of permutation will be 10 minus 1, that is 9 factorial. Next, find n if NC8 is equal to NC7. We know that from the property of combination, that is, when 2 combinations are equal, either A is equal to B or A plus B is equal to n. So here clearly we can't use the first property because 8 is not equal to 7. So hence, to find n here, it is 8 plus 7, which is equal to 15. Next, how many different arrangement can be made with the letters of the word Monday? So we have a word Monday, we have 6 different letters and we are arranging 6 different letters. So that's why it will be equal to 6 factorial. Next, how many straight lines can be formed from 10 points if no 3 of them are collinear? So that means out of 10 points, so none of them are collinear here. So that means here all 10 points can be used to form a straight line, and minimum number of points to form a straight line is 2. So therefore, we use the formula NC2. So therefore, here n is given as 10 C2, so that it can be written as 10 into 9 divided by 2 into 1. A simplest form of solving combination. So 10 into 9 by 2 into 1. So 2 1s are 2 5s are 9 5s are 45. So therefore 45 straight lines can be formed using 10 points where no 3 points are collinear. Next, if NP3 is equal to 210, find n. So here they have given NP3, so we can write this as n into n minus 1 into n minus 2. So NP3 can be written as n into n minus 1 into n minus 2. So therefore the first 3 factors from the previous. So if I have like 5P3, then I can write this as 5 into 4 into 3. That is the first 3 numbers from 5. So similarly we can write this as n into n minus 1 into n into 2. 210 can be written in the form of 7 into 6 into 5. So how by inspection we can write this as 7 into 6 into 5. So clearly you can see 7 into 6 into 5, and this is in the form of 7 into 7 minus 1 into 7 minus 2, which is in the form of n into n minus 1 n minus 2. So by observing these two on your LHS and RHS, you can clearly write n is equal to 7 by the method of inspection. How many different 4-digit number can be formed using the digits 1, 2, 4, 5, 7, 8, 9, no digit being repeated? When I say 4-digit number here, obviously it has thousands, hundreds, tens and ones place. So how many numbers I have? 1, 2, 3, 4, 5, 6, 7 numbers I have. So let's start filling the numbers from the ones place. I have all the chance of filling all the 7 numbers. When any one of the number is filled inside the one place, we are left only with 6 numbers in the tens place, because the condition is given no digit being repeated. None of them should get repeated. Suppose if I have written 4 on the ones place, then I can't write 4 on the other places like 100 or tens. So therefore, the remaining numbers for tens place is 6 and similarly 5, 4. So therefore, the total number of 4-digit numbers that can be formed using that number is 7 into 6 into 5 into 4. That is equal to 840. Next, we will see the 2-mark questions. So what kind of 2-mark questions you can get? In how many ways can 3 boys and 4 girls be arranged in a row such that all the 3 boys sit together? So we have 3 boys and 4 girls. The condition is that all the 3 boys should sit together. That means we can't put girls between the boys. So let us tie all the 3 boys as one single unit. They are in one single unit. So that means the position is fixed for all the 3 boys and we have 4 girls there. So that means we have 4 places for girls. This position may differ also. That means if I first place a girl here, then all the 3 boys come here. Then again we are left with 3 girls. So that means every time I should change the position of boys where all the 3 boys are sitting together. So total I have 1, 2, 3, 4, 5 places. So I have to arrange 5 places here. So where the boys, all the 3 boys can sit together. So therefore the number of arrangement will be equal to 5 factorial. So 4 factorial for girls and 1 factorial for boys. So therefore the answer is equal to 5 factorial. And also if I consider them as boy 1, boy 2, boy 3, they can also interchange their places but they are sitting together. For example, boy 3, boy 1, boy 2. Here 1, 2, 3, here we have 3, 1, 2. That means even boys can also interchange their place with them only. So therefore it will be into 3 factorial. So this is the total number of arrangement, both girls and boys, and this is the number of arrangement for boys. So therefore the number of arrangements of 3 boys and 4 girls where all the 3 boys are sitting together is 5 factorial into 3 factorial. Next, find the number of parallelograms that can be formed from a set of parallel lines intersecting another set of 4 parallel lines. We have a formula that is MC2 into NC2 where M lines intersects with N lines to form a parallelogram. So therefore here I can take it as 6C2 into 4C2. So 6C2 means 6 into 5 divided by 2 into 1. 4C2 means 4 into 3 divided by 2 into 1. So on cancelling this, so here we will get 15 into here we will get 6. So we will get 90. So therefore 90 parallelograms can be formed using 6 parallel lines intersecting with another set of 4 parallel lines. In how many ways 6 gentlemen and 4 ladies be seated around a table so that no 2 ladies are together? So first we have in around the table. So let me fill the position for 6 gentlemen. So the number of arrangement for 6 gentlemen around the table will be 5 factorial, because when I consider the circular permutation, you already know that it is 1 less than the arrangement. So therefore, it will be equal to 5 factorial. And I need to fill 4 ladies between the gentlemen. How many positions I have here? If I consider this as gentlemen, how many position is left for ladies there? 1, 2, 3, 4, 5, 6. Because they have given the condition that no two ladies can sit together. That means obviously they have to sit between gentlemen. So I have 6 position for the ladies, but I have only 4 ladies. So therefore it will be equal to 6p4. So that means out of 6 position, I need to arrange only 4 ladies. So therefore, my total number of arrangements will be equal to 5 factorial into 6p4. 5 factorial represents the arrangement of 6 gentlemen and 6p4 represents the arrangement of 4 ladies in 6 positions. And then you evaluate this, multiply and write the value. Next, in how many ways 6 people can be selected out of 12 people so that 2 particular members must be included. So that means we have 12 peoples here and I need to select only 6, out of which 2 has to be included. 2 particular members must be included means already 2 members are inside the team here. So therefore, I have left only 10 people here because already 2 of them are selected, and here also since I need to select 6, 2 are already included. The remaining is I need to select only 4 members out of 10. So therefore, for the question 2 particular members always included, the answer will be equal to 10C4. So this is the number of selection. And the second question says we need to choose 6 people out of 12 people where 2 particular members must be excluded. That means I need to remove 2. So if I remove 2, then I have 10 members. Obviously, I need to select 6 people again. So I have 6 people to select here. So therefore, for the second one, the answer is 10C6. So 10C4 is equal to 10 into 9 into 8 into 7 divided by 4 into 3 into 2 into 1. So we can cancel 4 2s are 8 and 8 here, 3 1s are 3 3s are 9. So 7 3s are 21, we will get 210. Here also 10C6 is same as 10C4 because we know the formula, that is 10C6 is same as 10C4. Why? Because 6 plus 4 is equal to 10. When this holds, the value of the combinations are equal. So therefore, for 10C6 also, the value is 210. So we have 210 ways to select the particular members. Next, in how many ways the word Keram be arranged such that 2 R's are always together? So when I say 2 R's are always together, tie them as one particular unit. We have here 1, 2, 3, 4, 5, 6 letters to arrange. Out of them 2 letters are repeating. But here since 2 R's are always together, we can tie them as one unit. So therefore here we have CA. This is considered as one single unit. 1, 2, 3, 4, 5 factorial ways. And what about R inside it? So here R, when you replace with R, the order doesn't changes. So therefore, the answer is 5 factorial only. Next, we will look at a 3-mark question. So in 3-mark question, so you may arise the questions which containing 3 sub-question based on permutation or any combination. So maximum you will get the problems on permutations only. So here, find the number of permutations of the letters of the word engineering. How many of these begin with green, have all 3 E's together, begin with E and end with E? First, let us see how many letters are there in the word engineering. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So total 11 letters we have. And if you have any letters which is repeating, count them. We have E 3 times. Next we have N 3 times. Next we have G 2 times. Next we have I 2 times. And we have R 1 time. So the total permutation, suppose you consider how many number of permutation can be formed from the word engineering, then it will be obviously 11 factorial by 3 factorial, 3 factorial, 2 factorial, 2 factorial. This is only the total number of arrangement. But we have a conditions here. So let's see. So for the first one, always the word should begin with green. So that means the position of the first 4 letters are fixed here. So we need to arrange only the remaining letters. What are the remaining letters here? So leave green here. So if you leave green, so you can take these 4 letters. If you leave here, so how many letters are remaining? 1, 2, 3, 4, 5, 6, 7 letters are remaining. So that means we have to arrange 7 letters here. And out of that 7 letters, we have the letters which is repeating. What are the letters which is repeating? E is repeating 3 times. So therefore divide by 3 factorial. N is repeating 2 times, divided by 2 factorial. Next I have G is not repeating, I is not repeating. So the only cases are 7 factorial by 3 factorial and 2 factorial. So next second case, it says that all the 3 E comes together. So that means they are tied as one unit. So if I tie all the 3 letter E as one unit. So how many letters are remaining now? So 11 minus 3, we have 8 letters, and out of 8 letters, we have a letters which is repeating other than E. What are those? N, G and I. So let us divide the total factorial by 3 factorial, 2 factorial, 2 factorial. And observe the letter E inside the unit. If you change the position of any E here, the order doesn't matter because it's E only. So therefore, here we doesn't have any into 3 factorial, because when you change the order of E, it doesn't matter here. Order will be the same. Hence, for the second question, you need to arrange only the 8 letters along with their repetition except E, because we need to tie them as one single unit. Next we have C. Here they have said the word begins with E, end with E. So when you have a word like this, so the first position and the last position are fixed. So we need to arrange only the remaining 9 letters here. So that means 9 factorial we have, and out of 9 factorial we have N 3 times, next G 2 times and I 2 times. And E will be single because the 2 E are given for the end and the beginning. So therefore we have only one E left and we can't divide it as 1 factorial. So this is the total number of arrangement for the given conditions. Next question. Find the number of permutations of the letters of the word committee. How many of these have all vowels together? First let us see how many letters are there. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 letters in total. So in 9 letters we have M, which is repeating 2 times, T is repeating 2 times, E is repeating 2 times. And how many vowels we have here? So 1, 2, 3, 4. So vowels is 4 here. So what are the vowels we have? O, I, E and E. So these are the vowels. And we have C, M, M, T, T. So these are the consonants. Now here for the first question they have asked us, we need to arrange the letters in such a way that all vowels are together. So that means tie all the vowels as one singular unit, O, I, E, E. So out of 9 letters, we are writing all vowels as one single unit. So then how many consonants we have here? We have 5 consonants remaining and 1 unit of vowel. So therefore 1 plus 5 is equal to 6 positions we need to arrange. So therefore we will consider it as 6 factorial. And out of 6 positions here, we have a repeating letters. So here M is repeating 2 times. So let us divide it by 2 factorial. T is also repeating by 2 factorial. This is for the 5 letters remaining. And consider the unit here. Here you have 3 different letters. So that means you have total 4 letters, out of which you have E repeating 2 times. So when you change any one position of the letters here, so that means the order changes. So therefore this will be equal to 4 factorial inside the unit, and where 2 factorial we have to write because E is repeating twice. So when you say all ovals are together, consider all ovals as one single unit. Remaining 5 letters along with this unit will be 6 factorial ways, but we have M and T as a repeating, so therefore it has to be divided by 2 factorial. Also here the ovals can also interchange their positions where E is repeating 2 times, so therefore it will be 4 factorial divided by 2 factorial. Next, for the second one, begin with T, end with T. So that means the position are fixed for T here, both the T's. We are left with 7 letters. So 7 letters means we need to arrange in 7 factorial ways, but out of 7 letters except T, we have M and E which is repeating 2 times. So therefore it will be divided by 2 factorial into 2 factorial. So these are the number of arrangements. Next, a team of 11 is to be chosen from 18 cricketers, of whom 6 are bowlers and 3 are wicket keepers. In how many ways can a team be chosen so that there are exactly 4 bowlers and 1 wicket keeper? Let us see now. We have total 18 members and we have to form a team of 11, and they have given in 18 cricketer there are 6 bowlers and 3 wicket keepers. 3 wicket keepers, and obviously the remaining one will be any batsman others. So that means we have 9 others. For the first question, they says the team must contain exactly 4 bowlers and 1 wicket keeper. So that means out of 6 bowlers, we need exactly 4 bowlers, 1 wicket keeper. Then to form a team of 11, we need still 6 members. So therefore, we need to select 6 from others. So therefore, my total selection will be equal to 6C4 into 3C1 into 9C6. So 6C4 can be written as 6C2. 3C1 is 3. 9C6 can be written as 9C3 because 6 plus 3 is 9. 2 plus 4 is 6 here. So it will help you for the simplification from the combination property. I can write this as 6 into 5 by 2 into 1 into 3 into 9 into 8 into 7 divided by 3 into 2 into 1. So I can cancel here. 2 1s are 2 3s are here. Again I can cancel 3 and 3 here. I can cancel 2 and 4 here. So it doesn't have any number in the denominator. We have 3, 5, 9, 4, 7. Multiply all of them. So the value will be equal to 3780. So next they have asked there are at least 4 bowlers and at least 2 wicket keepers. So let's see now. So minimum we need to select 4 bowlers and 2 wicket keepers, and we need to form a team of 11 here, but here we have 6 bowlers, 3 wicket keepers and 9 others. Now let's see what are the combinations I can get to form a team of 11. So now out of 6, this is the minimum requirement. So out of 6 bowlers, at least 4 bowlers has to be chosen. So if 4 bowlers has to be chosen, then we can choose 2 wicket keeper. 4 plus 2 is 6. So 6 plus 5 others will be there. Or if 4 bowlers are chosen, then we can also choose 3 wicket keepers. So here 4 others will be there. If I have chosen 5 bowlers, then minimum 2 wicket keepers. Then here I have 4 others. And here if I have taken 5 bowlers and then here 3 wicket keepers, here I will get 3 others. Or if I have chosen 6 bowlers here, then here 2 wicket keepers, then here 3 others. And here if I have chosen 6 bowlers, and here we have taken 3 wicket keepers, then here have left with 2 others. Now the selection is made, then with the use of combination formula, we can write this as 6C4 into 3C2 into 9C5. So here again we have 6C4 into 3C3 into 9C4. Next here we can take 6C5 into 3C2 into 9C4. So here we will get 6C5 into 3C3 into 9C3. Next here again 6C6 into 3C2 into 9C3. So the last one will be 6C6 into 3C3 into 9C2. So you need to find the value of all these. So here the value will be equal to 5670. So here the value is equal to 1890. Next we have 6C5 into 3C2 into 9C4. So next after multiplying we will get 2268 here. Next one we will get it as 504. Next one we will get it as 252 and 36. So in total, so it will be equal to 10,620. So this is the total number of selections we can make from 6 bowlers, 3 wicket keepers and 9 remaining players to form a team of 11 containing at least 4 bowlers and at least 2 wicket keepers. So next question, this question was very simple. It may ask for 3 mark question. Sometimes they'll give you for 2 mark question also. If a convex polygon has its 170 diagonals, find the number of sides of the polygon here. So the number of diagonals inside a polygon is given by nc2 minus n is equal to the value. So here the total number of diagonal is 170. nc2 means n into n minus 1 divided by 2 minus n is equal to 170. So let's multiply the numerator and let us multiply 2 to the whole equation. So here it will become n square minus n minus 2n is equal to 340. So we will get n square minus 3n is equal to 340. So or we will get n square minus 3n minus 340 is equal to 0. So from the quadratic equation we can write this as n square minus 20n plus 17n minus 340 is equal to 0. So when you take the factor we will get n minus 20 and n plus 17 is equal to 0. By equating the two linear factors to 0 we will get n is equal to 20 or n is equal to minus 17. Since we are counting the number of sides here, n cannot be equal to minus 17. So therefore n has to be a positive value. So therefore n is equal to 20. So these are the few questions which we have collected from previous year from this chapter. So here you will get 1 mark question, 2 mark question and 1 3 mark question, total 6 from this chapter. So in the next session we will discuss the questions and what type of question from the chapter probability. Keep watching, keep learning, keep exploring. Thank you.